Greetings, ladies and gents, and welcome back. It's Mike Maths and Science Club. In this video, we'll be looking at a question which was written in November 2022. It's question 6 on finance. So they said that, of course, as you can already see, that I downloaded this question from Stanmore Physics, quite a nice website with a lot of resources. So they said that 12,000 was invested in a fund that paid interest at M% per annum, compounded quarterly. So immediately after we hear that word compounded, so in this case we would immediately know that we are actually going to use our compound interest formula, which says that A is equals to P 1 plus I all to the power n. So they said that after 24 months, the value of the investment was 13,459 rand. So in this case, they said that determine the value of M. Now, M would be, of course, the interest, right? The interest rate. So in this case, they say that they want that interest rate there. Now, of course, what I love to do before I even start with the calculation would be to write what I call a shopping list. So in this case, we know that P was given as 12,000, and then A was, let me just shift that so that I would not run out of space there when I start the calculations. So in this case, I know that P was actually given as 12,000. Right, and A, which was the accrued amount, so this was 13,459, and then we know that of course I. Now remember, with the I, in this case we know that this interest was actually per annum, right, per year, compounded quarterly, meaning that we're gonna take whatever interest that we were given, and then in this case we'll divide it by 4. Now remember that in a year we have 4 quarters, so in this case we know that of course our interest would be M, but in this case divided by 4. Why? Because in this case this was compounded quarterly. In this case would be in a year would have 4 quarters. So in this case we'll take whatever interest that we have, and then we'll divide it into 4 equal parts. So in this case we know that I is equals to M divided by 4, and in this case we know that N. Now remember that N would be the number of times interest is added. Now remember that interest is added here 4 times in a year, right? In this case 4 quarters would be a quarter is 4. It's of course would be divided, that would be 4. We have 4 quarters in a year. So in this case, now remember this, they said after 24 months the value of the investment was 13,459, right? So in this case 24 months would actually be 2 years. Right, so since we have 4 quarters in a year, so in this case in 2 years we'd actually have 8 quarters. So in this case N would actually be 8. So in this case I know that of course A was given as 13,459 equals to P, which was 12,000. 1 plus, in this case my I, we say that's M divided by 4, so this would be M divided by 4 to the power 8. So what I would do in this case would be to divide by 12,000 on both sides. So what I would have would be 13,459 divide by 12,000. Now what I'm gonna do is I'm not gonna put that in my calculator for now. The reason being, I want to avoid the decimals, giving all the decimals. So what I have in this case would be 1 plus M divided by 4 all to the power 8. Then next I would just take the 8th root, right? So in this case I would have the 8th root, 13,459 divided by 12,000. So in this case this would actually be equals to 1 plus M divided by 4. So what I would do next in this case would be to transpose that 1. So in this case what I would have would be 8th root, 13,459 divided by 12,000 minus 1. So this would actually be equals to M divided by 4. Now again what I would do next would be to multiply by 4 right on both sides to get rid of that denominator there. So I would multiply by 4 on both sides. So what I would have eventually would be that 4 multiplied by the 8th root of 13,459 or divided by 12,000, but minus 1, and this would actually be equals to M. Now remember that M is a percentage, right? It's given in percentage. We know that I is given in percentage in this case. So in this case, what we'll do, whatever value that we're gonna get, when you put this in our calculator, would actually multiply that by 100, right? So in this case, we would know that M would actually be equals to 4 multiplied by the 8th root. 4, that's 13,459 divided by 12,000 minus 1, but in this case we take all of that, would multiply it by 100. So that's exactly what I'm going to do. So we know that of course we have 4 multiplied by the 8th root of 13,459 divided by 12,000, subtract the 1, right? But now remember that's not actually the cube root, so that was supposed to be 8. So in this case, what I would do, I would subtract the 1 and I multiply everything, and I would actually multiply everything now by 100. So this would be multiplied by 100. So in this case, what I would get would be M being 5.78%. So in this case, this would be the value of M that you would get. So in this case, for 6.2, so for 6.2, they say that on 31st January 2022, Tino deposited 1,000 in an account that paid interest at 7.5% per annum compounded monthly. He continued depositing 1,000 on the last day of every month. He will make the last deposit on the 31st December of 2022. So in this case, immediately would note that this is actually an annuity. How would we know that? Now remember that they say that Tino is actually making monthly installments, right, of 1,000 rand. So if at the end of every month, Tino would be making 1,000 rand. So in this case, we know that this is an annuity. So they say that will Tino have sufficient funds in the account on the 1st of January 2023 to buy a computer that cost 13,000? Justify your answer by a means of an appropriate calculation. Now we can't say yes or no. So in this case, we would need to perform the calculations first, and then in this case, we would answer that question. So in this case, what I'm going to do now, we know that of course this would be the future value annuity, right? Because we want to find out that how much will Tino have in the future, right? After that, after he makes his payment on the 31st of December 2022. So we know that in this case, I'm just gonna draw that timeline. So in this case, we know that Dino. So in this case, we would have T0 here. So in this case, we know that this would be at the beginning of January, right? So this would be, of course, at the end of January. So in this case, this would be the 31st of January, 2022. So we know that, of course, Tino made in an installment of 1,000, right? So also on the at the end of the following month, Tino made another at the end of February, Tino made another installment of 1,000. So in this case, until on the 31st of December 2022. So in this case, would be at the end of that year. So we know that of course in a year we have 12 months. So right. So in this case, this would be, now remember, this would be 1 month, second. So this would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be on the 31st. On the 31st of December. So would be December. I'm just gonna write that as deck. So in this case, this would be 2022. So we know that of course, so this would be the day that he makes his last deposit of 1,000, right? Now we know that of course the future value annuity formula says that A equals to P. No, actually now I'm lying. I'm very much lying. So we know that it says that FV is actually equals to X, right? 1 plus I divided by N minus 1, and we divide all of that by I. Now remember, now again, as I always love to do, ladies and gentlemen, we know that of course X is actually given as 1000. We know that of course I, now this interest was compounded, was per annum, compounded monthly. So we know that that 7.5% would actually be divided into 12 equal parts, right? So in this case, we know that in a year we have 12 months. So in this case, we'll take whatever interest that we have, we divide it by 12. So in this case, we know that we have, this would be 0.075, divide that by 12. So in this case, what would be the following? Now remember that in this case, the tenor would actually make would actually make 12 payments for that 1000. So in this case, now remember that N stands for the number of payments. So in this case, of course, in a future value annuity formula, so in this case, N would actually be equals to 12. So what we would have eventually, now what else would be left? I think we pretty much have everything. So in this case, we have of course FV would be what we are looking for. So I'm just gonna erase what we have down there so that we have somewhere to write. So in this case, we are looking for FV. We know that X is given as 1000. All right, so this would be 1 plus the interest, which is 0.075, divided by 12, all to the power 12 minus 1, and we divide all of that by 0.075 divided by 12. So in this case, I'm just gonna plug that into the calculator. So we have 1000 multiplied by 1 plus 0.075 divided by 12, all raised to the power 12. So we have that being to the power 12, and then in this case we subtract a 1, all divided by 0.075 divided by 12. So in this case, I get a value of 12,421 rand and 22 cents. So in this case, we have a fee being equals to 12,421 rand and 21 rand and 22 cents. So in this case, this would be the amount that Dino would have after he makes 12 payments. So in this case, so the answer to this would be no. So in this case, now we would have never known if of course it was going to be enough, of course, in this case, in order to purchase that laptop, which costed 13,000. So the answer for that would be no. All right, so in this case, let me just erase that again. Let me just erase my lovely timeline there. So in this case, would the answer for 6.2, so the answer would actually be no. So in this case, we justify our answer by that calculation that we have there. So in this case, for 6.3, they say that Tabo plans to buy a car that costs 250,000 rand. He will pay a deposit of 15,000 and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. Now, in this case, we know. Now they said that calculate the value of the loan. Now remember that the car cost 250,000, but in this case, Tabo would actually will deposit 15% of that 250,000. So in this case, what we can do, we're gonna find out that of course how much would be the deposit, and then we would subtract it from that 250,000, and then we would get actually the value that of the loan, that the amount that in this case Tabo would, Tabo, is it Tabo, that Tabo would actually take as a loan. So in this case, I'm just gonna erase that again, so that we have again somewhere to write. Now I'm just gonna write that aside. So in this case, for 6.3.1, so we know that of course the deposit is actually equals to 25,000, 250,000 actually, multiplied by, now let me just put this on this side so that I have somewhere more to write. So in this case, for 6.3.1, so we know that of course deposit, I'm just gonna leave that as depot. So this would actually be equals to that 250,000, right? We multiply that by 15%, which is 0.15, divide by, so in this case I would actually multiply it by that. So in this case you can just write it as 15 divided by 100. So in this case what you would get would be, we have 250,000 multiplied by, just say 0.15. So in this case you'd actually get so that would be 37,500. So in this case the deposit was actually 35,700. So this would be the amount that deposited, right? So in this case, so for the value of the loan, in this case what we would do, we would take first the amount that the car costs, we subtract the deposit to get the amount, the outstanding balance in this case, which would be taken as the loan. So in this case the loan would actually be equals to 250,000 minus 35,700. Is it 700? It's actually 500. Where did I get 700? Let me just erase that. I don't know where I got that 700. So let me just get out of there. So in this case, this will be 35,500. Just hope that it's actually 37. Jesus, Mike. So in this case, this is actually 37,000. This is actually 37,500. So that's 37,500. So in this case, I'm just gonna also erase that lovely 5 there. So this is the 37,500. So in this case, if we subtract that, so in this case, I'm just gonna take 250,000. We subtract that that amount there. So in this case, what you would get would be 212,500. So in this case, it would be 212,000 and 500. So this would be the balance of the value of the loan. So in this case, they said that the first payment will be made 6 months after the loan has been granted. They say that the loan will be paid over a period of 6 years after it has been granted. Calculate the monthly installment. Now remember that we can't actually use this value as our loan. Now remember, this is actually a present value annuity, right? Because in this case, we took, we have this money right now, and then we are trying to pay it back. So in this case, this makes this a present value annuity. Now we know that of course the present value annuity formula says that. Let me just scroll that down again, and of course erase that. So in this case, we know that of course we would have PV being equals to x 1 minus 1 plus I to the power negative n. All of that is divided by I. So in this case, what we have now, remember that in this case, the first payment was actually made 6 months after the loan has been granted. So the first payment was actually made at T6. So in this case, what I'm gonna do again, I'm just gonna draw a timeline. Right, so we know that of course this is where the loan was granted, right? So this would be a T1. So this would be a T1, right? So in this case the loan was granted, so that was that 212,500. So in this case it's actually a T0. So in this case this is where that amount is granted. But in this case we know that of course Dino actually started making the monthly installments 6 months after the loan has been granted. So in this case, Dino started to make the monthly payments at actually at T6. So in this case, if you have watched the videos that I made on finance, you would notice that in this case, what we're going to do, we're going to grow this amount, right? Because in this case, we say that built into the present value annuity formula is the idea that the one-time period must pass before the first payment is made. So in this case, we know that what we're going to now in this case we know that the first payment was actually made at T6. So what we're going to do, we're going to grow our amount in this case for 5 full months. So in this case we're going to grow this amount for 5 months, and then we'll find out how much would we have in this case at T5. And then 1 month after that we would actually start to make our first payment. So in this case we would have made 5 payments. So in this case what we're gonna do to that PV, we're actually just gonna grow it in this case for 5 months. So in this case if I modify that formula, what I would have in this case would be PV multiplied by 1 plus I to power n. Now remember that this n would be the missed payments. That's one thing that you must remember. So in this case, that n, in this case on that part would be the missed payments. So in this case, we say that this would actually be equals to x, and then we open brackets. So we have 1 minus 1 plus I, or to the power negative n. So in this case, this n and that n, they are very much different. So in this case, this would actually be the number of payments. So in this case, what we're going to do, we're going to divide everything by I. I'm just gonna erase what I wrote there. So in this case, we know that of course the loan would be that 212, right? But the interest that it accumulated in this case for 5 months, while it was just lying into the account. So in this case, this would be 500 multiplied by 1 plus the interest. They say that it was charged at let me just double check that. So in this case, that was 13% per annum compounded monthly. So in this case, we would take that 13%, we divide it by 12. So in this case, this would be 0.13 divided by 12. All of this would be to the power 5, which is the missed payment. So this would actually be equals to x, which is what we are looking for again. So this would be 1 minus 1 plus I, which is 0.13 divided by 12, all to the power negative. Now remember now that in this case we know that Tino started to make the first payment at T6, right? So at T7, so he made another payment at T7, T7 and T8, 9, 10, 11, 12. So this would be at the end of the first year. So in this case, in that first year, we would actually make 7 payments, right? So in this case, we know that of course Dino missed 5 payments, right? So in this case, we know that in a year, we're actually expected to make 12 payments. But since Dino missed 5 payments, so in this case, the payments that we would make in that first year would actually be 7, right? So again, let me just write a shopping list again. So in this case, we know that P was given as that. So P in this case was PV multiplied by, so in this case, let me just write that down. So in this case, that PV was actually 212,500 multiplied by 1 plus 0.13 divided by 12, all of that to the power 5. So in this case, we know that so this would be PV. In this case, we are looking for x, which is what we don't know, but we know that I in this case was given as 0.13 divided by 12. Now in this case for n, now remember n would be the number of payments. So they say that the loan will be repaid over a period of 6 years after it has been granted, after the loan has been granted. So in this case, now remember, in the first year, Dino made 7 payments, right? But in this case, in the remaining 5 years, Dino would actually make 4 payments. So in this case, it would be 12 payments in those other years. So in this case, n would actually be equals to 7 plus, in this case, 12 multiplied by 5, right? So in this case, that would be, so in this case 12 multiplied by 5, in this case that would be 60 plus 7. So in this case the number of payments would actually be 67. So in this case we know that's negative 67. All of that is divided by 0.12 divided by 12, actually it's 13 divided by 13 divided by 12. So in this case I'm just gonna scroll down again. So what we have, so what we're gonna do now, I'm just gonna put this whole thing that I have here in my calculator and find what that value would give me. And then what I would do, what I would know that whatever that value I'm gonna get, there would be the coefficient of x. So in this case we have what we have would be, that would be 1 minus 1 plus 0.13 divided by 12, all of that to the power negative 67. And then we close that, divide all of that by 0.13 divided by 12. So what you would get actually would be x multiplied by 47.463 and of course 343, and of course some other lovely cents. Now in this case we can't round off, so in this case that's not actually equals to, so that would be multiplied by, so this would be multiplied by, right? So in this case would have, let me just rewrite that whole thing that I have going on there, that x, so that it's not separate. So in this case would have x there, so this would actually be equals to, so in this case we have that 212,500 multiplied by, and I'm just gonna put that into the calculator and see what I would get actually. So I'm just gonna shift store that at A. So in this case what I would do, and just clear that. So in this case I have 212,500. We multiply that by 1 plus 0.13, all divided by 12, and we multiply that, we all raise that to the power 5. So in this case what you would have again are those lovely cents again. So in this case we're just gonna take what is this value here, right? The value that we have going on there into that calculator, and then in this case you would divide it by this coefficient of x. So in this case what you would eventually have, let's see if we can write that whole thing there. So in this case I'm just gonna shift, I'm gonna store this also at B. So what I have now happening would be would be B, rather would be B divided by A. So that's actually divided by alpha A. So in this case what we have happening there would be x being equals to, so let me just erase what I have here now and just write that in a proper way so that it doesn't confuse. So we have 212,500, 1 plus 0.13 divided by 12 all to the power 5. So in this case I took this whole thing that I have happening here and then I divided it by the coefficient of x. So in this case what we had was 4,000 So we had 4,724 to in the 96 cents. So in this case, the monthly installment that Tabo would need to make in this case in order to settle that loan would be 4,724 and 96 cents. I hope that I have been some help at some point. But otherwise, ladies and gentlemen, this is the end of this video. And of course, if it helped you at some point, hit that like button. And if you have any questions, you are more than welcome to throw your questions in the comment section. And of course, if you have a question that you would love me to do, since we are actually here almost at that. Since we're almost at the end for that final maths paper, you are more than welcome to suggest it so that I can be able to help out, if of course, yeah, so that I can be able to help you out so that you can actually be able to ace those exams. But otherwise, ladies and gentlemen, as the story always ends, this is Say Mike signing out. Sharp sharp.